def. X def. We have list A, list A, end A, and then the next page, X def for export, list B and end B. List B and end B, and then finally we have list C and end C. Okay. Now I have given you load points. Prog A loads at 300. So what's the actual value now of list A? What's the actual value of list A? Prog A loads at 300, 300. Now what's the address of list A? So the actual address is that, isn't it? Now wait, where'd that come from? Is that the actual address, or am I been smoking crack? What's the actual address? Is this right? Where did it come from?
You added the loading address to the...
You added the loading address. Yes, if you loaded it at address 300, then you add 300 to all of these to get their actual addresses. So then end A, yes. That's the actual runtime value. Okay. Program B loads at 1,000. Not 1,000, but it's hex. Okay. So list B had address 60. So list B gets 1060. Are we good? What's in B? Good. And then we have list C. And list C loads at 3,000. So list C is what?
3030.
And NC? Are we good? Now we're home free. Now we're home free. So back to A. Let's transform prog A. We're doing the linking now so that these symbols can be found. All right. What does linking mean? If I ask you to describe in a brief paragraph what a linker does, what does a linker do?
It loads parts of a project into the bigger one, or like parts of code into the bigger one.
No, you're on the right idea. You're not wrong, but we want more precision. Kenny, you have to take a stab at it.
It combines code and these references to point to between them?
Okay, the linker provides information so that you can refer to code outside the current block. So it defines references that are in other files so that you can get to them. And of course, this is the only way we write code anymore. Okay, let's do this first page. All right, we have our first modification record at address 24. Oh dear, there isn't an address 24, is there? Well, okay, there is a 24, but it's not listed. What to do?
It's after the 77.
Yes, it's after the 7-7. Did everybody find it? Okay, so I'm gonna erase over here and work on these. So the existing instruction that we need to modify is 77100004. This byte here is 23. This byte is 24. And then 25 and 26. So this modification record says go to 24 and do 5 half bytes and add list B to it. So we have 771000004. It's 5 half bytes, which is 5 hex digits. Plus list B, it says in the modification record. Plus list B. Okay, list B is 01060. That's the actual list B. So we have plus, we have 77101064. That address is changed as it's loaded into memory to 77101064. And that gives us the actual value of list B plus 4. Everybody got it? Not terrible, huh? Okay. We have one more to do. Address 54. Do we have an address 54? We do. We do. What's different here? Notice the size on this one is 6 instead of 5. Why is it 6 instead of 5? It's a word. Understand that the addresses with this architecture, they're 5 half bytes. It's 5 hex digits, right? 1 megabyte. 2 to the 20. But that doesn't really work with memory. Words are 3 bytes, 6 half bytes. So we have 2 sizes of things. So if you have a word and you have an address, and the first character, the first digit has to be 0. It has to be. No other choice is possible. But we have 2 sizes. So here I've written 5 digits. I could have written 6. They're interchangeable. If you're writing an address in memory, it's 6 digits. If you're doing it, however, with a format 4 instruction, it's 5. Right? Okay. So we have 000014, and we have to modify that. So it says go to address 54 and take 6 half bytes, which is, and add list C to it. List C is 3030. And what do we have? 003044. This isn't terrible, is it? Okay, next page. I'm going to run out of time, so I'm going to try to move these along more quickly. Address 37. There isn't a 37, there's a 36. So what do we have? We have the instruction 031, and then all zeros. Okay, and what do we have to do? We have to add list A to it. We have to add list A to it. Well, list A is 340, which then gives us too many digits. they get so many? That's 5. 1, 2, 3, 4, 5. That's right. Okay, I can't count. There they are. Are we good? Now we have at 3E. 3E we have 0, 5, 1, 0. 0, 0, 0, 0. So it says add end A. Okay. 3, 5, 4. And now we have minus list A. And list A is 340. So we have 0, 5, 1, 0, 0, 0, 1, 4. Does everybody get that? Good. 70. The last instruction. So it's all zeros. The very last one on this page. There. Plus end A. Okay, end A. 3, 5, 4. Plus end A. Minus list A. List A is 340. So we have 0, 0, 0, 0, 1, 4. Plus list C, and list C is 30, 30. And we're left with 30, 44. That's what you got? Yes? Okay. Last page. Address 19. Plus list A. Okay. So that one is 0, 3, 1, 0, 0, 0, 0, 0. And we have to add list A to it. And that's 340. All right, so that is at address 18. 1D, 1D. So we have 7710. 0004, and what do we have to do with this? Plus list B. List B is 1060, which leaves us 7710, 1064. Everybody see that? Questions? Easy? Okay. I want to do the last one. The very last one. What's this Prague C business? Okay, end A minus list A plus list C. Well, list C's already in there, it's done. So we have this. That is the plus list C. So now we have plus end A. Okay, end A is 354. 0000384 minus list A minus 340 00044. Now is that in fact list C plus end A minus list A? Yes. Okay. And finally, we have plus Prague C. 3044. Not too bad. So this